Well done for completing the first module. You should now understand the basics of electrical engineering. In this module, we will develop your knowledge further and introduce some electrical laws. I hope you enjoy it. The aims of the course today are to show some of the standard units that we use in electrical engineering, from big to small. To introduce Ohm's law, a very basic law which links voltage, current and resistance. And review Kirchhoff's law and show how it can be used. Here are some of the unit prefixes that we commonly use. The first is P or pico. That's a billionth of a unit. E.g. 1 picofarad equals a billionth of a farad. Next is U or micro, is a millionth of a unit. E.g. 1 microvolt equals 1 millionth of a volt. Next is M or milli, that's a thousandth of a unit. E.g. 1 milliohm is a thousandth of an ohm. Then we have K or kilo, that's 1,000 units. E.g. 1 kiloamp is 1,000 amps. Next is M or mega, that's a million units. E.g. 1 megavolt is a million volts. And finally G or giga, that's a billion units. E.g. 1 gigawatt is a billion watts. Here is the first of the electrical laws that we'll be looking at. Ohm's law relates current, voltage and resistance. V, which is the voltage measured in volts, equals I, which is the current measured in amps, multiplied by R, which is the resistance measured in ohms. In most systems, the voltage is fixed. Therefore, as the resistance increases, the current reduces. Here is a worked example. For a circuit which has a voltage of 240 volts and a resistance of 40 ohms, calculate the current drawn from the system. V equals I times R from Ohm's law. Therefore, transposing the equation, I equals V over R. Therefore, putting the numbers in, I equals 240 volts over 40 ohms. Therefore, the answer is I equals 6 amps. Let's now introduce Kirchhoff's current law. In Kirchhoff's current law, the sum of the currents flowing into a node equal the sum of the currents flowing out. Let's look at a wire. Let's place a node at the central point of the wire. I in is the current flowing in, and I out is the current flowing out. Using Kirchhoff's current law, I in must equal I out. Let's use our water analogy again. Here we have a pipe with end A, end B, and a node in the middle. Kirchhoff's law says that the water flowing into one end of the pipe must equal the water flowing out the other end. What happens if the pipe develops a leak? By using Kirchhoff's, we can quickly detect the leak. Let's look at a network branch. Here we have a branch with ends A, B, and C. To analyse the circuit using Kirchhoff's current law, place the node at the point where the current split. Put the node here. The current flowing through end B is IB. The current flowing through end C is IC. The question is, what is the current flowing into end A? Well, it's pretty simple. IA equals IB plus IC, therefore the currents balance. Kirchhoff's law works regardless of how complex the system becomes. It is a very powerful and quick way to check that the system has no leaks and is healthy. Here is a worked example. Here we have a more complex network with ends A, B, C and D. Some of the currents are flowing into the network and some of the currents are flowing out. The question is, what is the value of missing current ID? Firstly, choose the best place for the node. This should be the main junction of all the currents. Here is the best place to put the node, where all the currents converge. Summate all the currents entering the node. I in equals IA, which is 30 amps, plus ID. The next stage is to summate all the currents leaving the node. I out equals IB, which is 40 amps, plus IC, which is 120 amps, equals 160 amps. Total current in equals total current out in Kirchhoff's. Therefore ID is 160 amps minus 30 amps equals 130 amps. Kirchhoff's current law is used throughout the electrical network to quickly check if the system is healthy. Here we have our complex network again, with ends A, B, C and D. Again, some of the currents are flowing into the network and some of the currents are flowing out. If we measure all of the currents in a healthy circuit and summate them all together, what will be the total? Here we've measured ends A, B, C and D, so what will be the sum of the currents? In Kirchhoff's current law, total current in equals total current out. Therefore, the sum of the currents must equal 0. This is a quick and efficient way to see if the system is healthy. Let's summarize what we've learned today. We can use Ohm's law to show the relationship between current, voltage and resistance. As the voltage is normally constant, when the resistance increases, the current decreases. In Kirchhoff's law, total current into a node equals the total current out of a node. It is a very powerful law which can be used to check the health of an electrical system. Congratulations for completing the first 2 sections. You are now well on the way to understanding the basics of electrical engineering. I have attached some test questions in the course content. Please try them before going on to the next section, which will show you how to use vectors.